TrueBench is designed to install quickly into a Windows or Linux environment that you already use to connect to your DBMS. If you're running very short tactical queries, it's important to run from a platform that is physically close to the DBMS on the network to minimize the impact of latency. Otherwise, the network can distort your results. TrueBench includes support for multiple DBMS platforms, and additional sources can be added through ODBC. You define your database connections once as aliases, and then reuse those aliases across your tests and scripts. Once set up, you can validate connection performance, define tests, and analyze results. In this demo, we'll set up the software on Windows, define database alias, and validate the connection to the DBMS. We've downloaded the latest release from the TrueBench website. I put it in the demo directory. We'll unzip the download. And now we have the software installed. In Windows, you can just begin by running the truebench.bat command. On Linux, you may want to make the truebench.sh executable. And now we'll start running TrueBench. It will create a virtual environment for Python, so you won't need any admin privileges to install software. Since this is the first run, you'll see suggestions to use the help command, or man, short for manual, which provides a full-screen help interface. You can scroll through the help text using the arrow keys. F6 shows an index of all commands, and F5 shows help topics. You can select a topic by scrolling down to it and then pressing the Enter key. The setup instructions indicate that we should create a startup file named truebench.tdb containing the db commands. The db command defines a connection alias. It includes the driver, URL, user, and password. When you press the escape, it'll return to the previous screen, and F3 exits the help system. While working interactively, you can also use the help or man command followed by the command name to get targeted help. For example, we can find out what the syntax is for the db statement and the syntax for the list command. Before defining an alias, it's useful to see what drivers are known to TrueBench. For this demo, we'll use the Teradata driver. Now we'll exit and define database aliases for our tests. The startup file is named truebench.tdb. We use .tdb as a suffix for scripts. What you see are the instructions that were displayed when we first started TrueBench. TrueBench follows OS conventions, but the echoes and comments you see are interpreted by TrueBench. We'll define a database for TD. Teradata is the name of the driver. The URL is going to reference a Vantage that is running on my laptop, so I'll use a local IP address for the URL. For the user, we'll use the standard administrative user and administrative password. In practice, you should use your own credentials. For the password, you have several options. You can put in a question mark to have it prompt you at runtime, or use the TrueBench read command in the script, or reference an environment variable. I'll also add in 3 additional commands that we'll explain in a later video. The first 2 define SQL to run before and after each test. In this example, they insert and update a row in the test tracking table on the host DBMS. This allows you to correlate your test execution with the DBMS query logs, so you can analyze what the system was doing during the test. The third command copies any notes that you enter into the local database for a test and copies those to the host tracking tables. We'll save the file and restart TrueBench. This time, when it processes the db command, it will prompt us to install the Teradata SQL driver. The driver will be installed into the virtual environment established when you first started TrueBench. Now we can see if the Teradata driver is available. And when we list the defined database aliases, we can see our Teradata alias. If your test needs multiple logins for users with different privileges, or to use system-level monitoring of the test, you can define multiple aliases to the same DBMS. Before proceeding, we should validate the connection. The validate command tests connectivity and measures latency by executing trivial queries for a fixed duration. Here it has executed 233 queries in about 5 seconds with an average response time of 21.5 milliseconds. That means a 0.5 second query will appear roughly as 0.52 seconds, and a very fast query, say 1 millisecond, will appear closer to 20 milliseconds. So that gives you a baseline for interpreting test results. At this point, we've done more than just install software. We now have a working environment where we can define and reuse database connections across all tests. That means we can start testing immediately without repeating setup steps or reconnecting each time. More importantly, this gives us a repeatable foundation. Every test we run uses the same connection definition and environment, allowing them to be consistently tracked and compared. And with the before and after run hooks, we can also capture what was happening inside the database during each test. So this isn't just a setup, it's the foundation for building reliable, repeatable performance tests.